Guys, so this is the next two problems, 28 and 38, 16a. So let's take a quick look. Write the chemical equation that illustrates the autoionization of water. So I'm going to start off here by writing water, and then I'm going to write it again. And what happens here is that one gets an extra H plus, the other one loses one, like that. That shows you how that splits apart. Here what I'm showing is for the Brownstedt-Lowry theory, this is the hydronium ion, which is very similar as if I just had one water splitting up into that. Very similar. These two we can use interchangeably because it doesn't make a difference for us. But there are times when it actually does make a difference. So we're going to ignore like the difference for now because we're just kind of like scratching the surface of acid-base chemistry. So write the expression for the ion product constant of water. That's very simple. We know that Kw equals 1 times 10 to the negative 14th, and the actual that actually looks like then, because all of these H2Os are liquids and do not show up. It's just the concentration of H plus times the concentration of OH minus, like that. And that's 1 times 10 to the negative 14th. As the solution is described as basic, what is meant by the statement? So here's what happens. That means that I have here 1 times 10 to the negative 7th for the H plus, and for the OH minus 1 times 10 to the negative 7th as far as concentrations. Oops. Doesn't matter. So what does it mean to be basic? Well, it means that this concentration for OH minus must be greater than 1 times 10 to the negative 7th molarity. If it's larger than that concentration, then the solution is basic. Okay, so the solution must have, here, I need more room. Let's do this. An OH concentration more than 1 times 10 to the negative 7th. Then it means it's a basic solution. Okay, that's all it means. Let's move on. Moving on here means that we get to this. Now this is like a chart that you have to fill everything else in. So let's take a look at, first of all, we're going to use 4 different equations. They're actually not that different. They're all very similar. So we can do one of two things here. We can talk about pH. We can see how pH plus, come on, Bensing. This is killing me here. pH plus POH equals 14. Okay, that's one of them. And hydrogen ion concentration times OH concentration equals 1 times 10 to the negative 14. We can use those two, and then what we can do is, so it's actually not 4 equations. I'm going to use 3 equations because the last one is pH equals the negative log of the hydrogen ion concentration. Now, if you want to get technical about it, of course you could do, it could be 4 equations. I could do exactly the same thing like this and have it equal to the OH concentration like that. So here's how this works. This one here is going to be using this equation. These two here and here on this side are going to be using this equation right here. Okay? Now to go from one to the other, from pH to the hydrogen ion concentration, or the POH to the OH concentration, I'm going to be using these 2 equations. Okay, so let's like take a run through this. I'm going to have to erase some of this because I wrote in the actual chart here. So I may have to highlight this and drag it down a little bit. Give myself some room, just like that. take a look. Now, so here's how this works. I'm going to go straight across with this. It's going to be pH plus POH equals 14. So that means 14 minus 4.75 equals 9.25. So 14 for this, I get 14 minus pH equals whatever the POH is. And in this case, it's 9.25. Now for this one here, I'm going to use the reverse of the pH equals negative log of the hydrogen ion concentration. So what I do for that is I very simply take 10 and then the minus 4.75. So here's where I plug in the pH and I have to use the minus sign for it. So on my calculator, I look for a 10x, right? My 10x then is, I type in 4.75 from my iPhone calculator, hit the minus sign, the plus minus, which means it's a minus 4.75, and then I hit the 10x, and that gives me this concentration. So this concentration here is 1.778, I guess I don't have to go that far, 1.78 times 10 to the negative fifth, like that. Now to do this one, all I have to do is take 1 times 10 to the 14th, 1 EE 14 negative, and then divide that by 1.78 EE 5 negative. And then I get this one. So this gives me 5.62 times 10 to the negative 10. Okay, so let me just write down again what I did for this one right here. So for this one right here, I took 1 times 10 to the negative 14 and divided that by the hydrogen ion concentration. 1.78 times 10 to the negative fifth, like that. And what I got was 5.62 times 10 to the negative 10. Okay, so that's how you do the first one. You go all the way across. I'm going to do the second one for you, and then you guys will have to figure out how to do the rest of them. It's not that bad, not that tough, because when we get down here, I didn't finish this. I look at the pH. If it's less than 7, it's an acid. If the pH says more than 7, then it's a base. So here I take a look at, this is my POH. I take 14 minus 11.89, okay, and that's going to equal my 2.11, which means that this is, again, an acid, like that. You know what? I'm going to let you do the H plus and the OH minus concentrations here. You can do that the same way I did it on top, by using the hydrogen ion concentration equals 10 to the negative pH. That's our formula. That's the opposite of the one I wrote down at the bottom there. So go ahead and throw in this number to the negative 2.11 over 10. So let's do one of these going back in this direction. So this is the hydrogen ion concentration, which means to find the pH, I'm going to do pH equals negative log of the hydrogen ion concentration. That's the formula I'm going to use. Okay, so here's how I do that. I got 6.5 EE 3 negative, like that, and I get this number here, 0.0065, and then I take the log of that, and then I simply make it, I hit the plus minus. So log of that gives me a negative 2.18 for the concentration from this, which means this is, of course, again, acid. Okay, now how do I find the POH? I take 14 minus this number here. That's it. So pH equals the negative log of the hydrogen ion concentration. Now for this one here, I can very simply take 1 times 10 to the 14th, like this, negative, and divide it by 6.5 times 10 to the negative third, like that. And what do I get? And I get something that looks like 1.53 times 10 to the negative 12th. Ooh, bonehead. I should round up there. Negative 12th, like that. Okay? So that's it. You can fill in the rest of those blanks. Let me know if you have questions. That's good. Stay tuned for question number 40.